Jahan.
Here we are again. What a time to be alive.
Back at it.
So just before we started recording, we were just chatting a little bit about night shift, which is what you just started.
Yes. Not a terribly healthy or beneficial regime to be under for your body, but it's a necessity of being a doctor, unfortunately.
It is. I always found night shift, I always find night shift when I do it to be actually one of the more enjoyable shifts. Like the type of work you're doing is kind of, I don't know, it's nice. In a sense, like it's low stress, usually low stress depending on what type of job you're doing. But surgical nights are generally low stress most of the time, and then occasionally high stress.
Yeah. It can spiral out of control quickly because the low number of staff and the high number of patients you're responsible for. But I do understand what you mean, where it's a lot of the times you're just putting out fires, but it's only when you can't get to all of them quick enough and it sort of turns into a bit of an inferno sometimes. But
yeah. I think there's a big difference between medical nights, which is what you're doing, and surgical nights too. Maybe people who aren't in the biz don't appreciate that subtle difference, but but the patient cohorts are really different. Like most of the time, the type of surgery you're doing is elective.
Yeah, and so, which is to say that they're relatively healthy most of the time, right?
Yeah, like there's a patient selection bias, whereas people who are getting admitted under medical units generally are not crisp.
Yeah, hence their requirement to be in hospital.
Yep.
I love the feeling of Kenopsia, though. That's a nice little fancy word drop for the feeling you get when you're when you're in a place that's normally crowded and it's not. So you're walking around these hallways that are normally, flushed with people, and now you're the only one sort of strolling around. The elevator's always empty, the stairwell's empty. Very odd feeling. And interestingly, actually, we've just had daylight savings here in Victoria. And I was receiving handover from one of my colleagues about, because I'm responsible for the cardiology ward as well. And on Monday, so daylight savings was Sunday, we went forward an hour, so you lost an hour. And some of the literature points out that this is one of the highest risk times of the year for cardiac events on like a global scale. And my colleague was complaining that they had 22 cardiology admissions in 24 hours on the Monday, and it was sort of an unprecedented sort of day for them. And I said, that makes sense actually with daylight savings. Like you lose that hour and you have a huge spike in cardiac problems.
Something like, I don't know, up to 30% spike reliably.
Yeah. And then you see a 30% drop pretty reliably when we gain an hour. So it's not a very heartening statistic when you're the one on nights losing a lot of sleep and you've got evidence to show that it's really not that good for you.
I think as the controversial public figure Jordan Peterson would say, it's no joke.
Yes, definitely. But enough of night shift. We're here to discuss alpha ketoglutarate. Is that right?
Yeah, absolutely. Which annoyingly, I cannot shake the habit of saying glutamate. It's really frustrating for me personally, just in my day-to-day life. But yeah, alpha ketoglutarate, a pretty interesting supplement that has an interesting history, I guess.
Yes, yeah. Do you remember interacting with it before becoming a doctor or anything like that?
No, not at all. But I am aware that it is big in the supplement biz for bodybuilders. Yeah.
I had interactions with it like that. I've always been into martial arts and fitness, but I got into proper gym work when I was maybe 17 or 16, 17. A lot of my friends all had their different supplements and True Mass and No Explode, all these sort of fancy little things. And that was at a time in my life when I wasn't medically inclined at all, and I would read the back because I thought I was a smart individual, and alpha ketoglutarate is going to make me bigger, stronger, more blood flow to the muscles, they'd mention
Maybe
a term
it does.
like nitric oxide, and you'd look that up, and okay, yeah, that increases blood
sick
flow.
for the pump.
Yeah, yeah. Sort of just enough keywords to leave the breadcrumbs along for you to, go into the right area of the internet to discover that you're correct.
Absolutely. The bro science is strong with this one.
Very strong. Very strong.
But there's some real science, real interesting science associated with it. And I think it's not actually simple to really get a grips with what alpha ketoglutarate is doing.
Yeah, because like a lot of the molecules that we talk about, they're so ubiquitous in the cell. They've got so many functions. It's not the cell's doing everything it can to use one thing for 10 different results.
Yeah, absolutely.
It's a very fascinating little system that we keep analyzing. And
so complex.
It's not one thing for one job. This one amazing little molecule can do 15 different things.
Yeah.
And sometimes in an antagonistic way, that one from one to the next, which is confusing.
It's really confusing. Man, I think that there are so many times it crops up like that where you think you understand how something works, and then you change one feature of that and it will change its function completely. My favorite example of that is like parathyroid hormone.
Right.
Which is, in kidney disease, you will get constitutively active parathyroid hormone, which causes your bone to release calcium into the bloodstream, right? And so it breaks down bone and you get osteoporosis. But somewhat and so you think, parathyroid hormone, more is bad. Like that's the simplistic linear human thinking.
Yeah.
But then you take the parathyroid hormone and you pulse it and you give it intermittently. So you have these small peaks every now and again. And all of a sudden it causes your bone to suck in calcium and strengthens your bones. It's just like body, what are you doing, bro?
Yeah. As my father-in-law pointed out the other day, he said a lot of this stuff accesses the fourth dimension, which is a very intelligent way of putting it, because the fourth dimension being time. It all depends on the timing of when this molecule is activated or for how long, such as with PTH. Yeah.
One of the things just as a slight digression, one of the things I thought was really interesting was that this idea that a lot of the fathers, or the creators of modern molecular biology, were actually physicists. And what's interesting about that is the way you think about these things, or the way physicists approach the dynamics of a system. They work a lot with partial differential equations. And I don't know if many people who may or may not be listening out for our humongous audience, but partial differential equations, I've played around with them and they are conceptually difficult. They can be really difficult. Even something as simple like the classic partial differential equation that is always introduced is like the heat equation, and modeling how heat disperses along a metal bar, and even just grappling the time components and the derivatives of the functions and how they all interact is difficult to conceptualize, because you're dealing with these dimensions and derivatives and but it's a model of what's happening, and it's a good model, and then you try and you spend a second trying to think, how would that fit in a biological system, and your mind explodes. It's hard. It's really hard.
And it's a byproduct of being on the cutting edge, right? Where we wish we had more answers, but it's somewhat of a nice signal marker to point out that we don't have the answers, because we're right there. We're right on the edge. We're just waiting for the next few studies to come out, and then we'll be able to answer some of those questions, hopefully. And more often than not, it just produces more questions or more questioning remarks. But I kind of like that, to know that, we're right there on the edge, and we wish we had more information, but it sucks to be,
it's kind of like
on the cutting edge
sometimes. A wave that never ends, because you're always on the edge.
Yeah, exactly. That belongs on the back of a car and a sticker.
Yeah, definitely. And the car it should be on is a combi van.
Oh, definitely.
But alpha ketoglutarate, we've sort of digressed about how complex it is, but maybe we should actually talk about what we kind of do know.
Yeah, I think a lot of people would have interacted with it in studying the TCA cycle, which is like how would you break that down? Just a way the body generates energy, I guess. And it's a very key component in that process.
Yeah.
So sort of anything that you see in that process is going to be important, and alpha ketoglutarate just happens to be one of the things that's been further investigated and has produced some fantastic results talking about longevity.
Oh, absolutely. The TCA cycle, also known as the Krebs cycle, and I always like finding historical figures whose first names are Adolf. And Adolf Krebs.
I can't think of any.
The other one is Adolf Sax, who invented the saxophone.
Nice.
So those are two straight off the bat. It's really unfortunate how maligned that name became.
Yeah, that's a very good point.
Dolph Lundgren narrowly escapes because he is like one letter off being Adolf.
Close. He's a Kyokushin guy. He does my karate, part of my group.
Oh, no kidding.
Yeah, we like to claim that at every opportunity. That's why I dropped it.
As another slight digression, an interesting figure, chemical engineer and like all round.
Yeah.
Cool guy.
Cool guy.
Yeah. So Adolf Krebs, the Krebs cycle, critically important cycle in the cell. Providing energy and interacting with things like the mitochondria, affecting the redox state of the cell. The redox state being often talked about as that NAD plus NADH ratio.
Yes,
which, as you can imagine, then has flow-on effects to, sirtuin activation and like all the other things that NAD plus is important for.
Which we will get to. That's another topic in and of itself.
Yeah.
It's hard to do podcasts when you focus in on one particular part of a cell or a process, which is how we've decided to sort of run this show. But ideally, you need to understand all of it to understand any individual podcast, which is a problem you can't really get around. But for the astute listener who's putting a picture together of all of our different podcasts, to say that this molecule is part of the energy cycle should point out that this is in the same sort of sphere as some of the other mechanisms we've talked about. We want to, if you're fasting or doing time-restricted feeding, you're sort of showing your body, look, there's not much energy around. You should probably hunker down and try to survive. And it's pointing out that alpha ketoglutarate is part of that energy cycle sort of points to the idea that it is involved in the same sort of pathways. Trying to trick the body into hunkering down.
Super interesting stuff. The way I would classify this is another one of those tools that affects cellular aging.
Yep.
But I think we touched on it last time with senescence, but the basic framework that I like to think about it is you have tools that affect the level of the cell, then you have tools that potentially tools that can affect the interaction of cells, and then tools that can affect, broadly like the whole organism.
Yeah, yep.
And they're all linked. But this is one of those ones that affects the level of this intracellular components.
Yes, I would definitely agree with that statement.
Yeah.
And then we're looking at specific scientific studies that have looked at fruit flies, worms, and mice. There haven't been any really focused human trials of what we're going to discuss, like this molecule actually acting in humans to produce the longevity. But there's a very long history of safety with this drug, largely from the supplement business. I mean, there's a lot of people who take alpha ketoglutarate, including myself and you, as I understand it. So we know it's safe, and we know it's been well marketed by supplement companies to give you all these gains in the gym. which may or may not be true. But to discover in these animal models that it's producing longevity is a win-win. Now we've got something that we can sort of safely ingest and know that it's not going to cause too many issues, and has this fortuitous byproduct of producing longevity.
Yeah. I always find it interesting when you find a conserved behavior across organisms. So you mentioned, worms, you mentioned fruit flies, and you mentioned mice. So that's 3 very different organisms that all have some benefit from AKG supplementation. But the literature is not always aligned about what those effects are.
Yeah, that's a good point.
I guess we could just talk about the effect on mTOR and autophagy in the first instance. What some of the literature says about that.
Yep.
Yeah. Because some of the literature definitely says it acts on the mTOR pathway to inhibit it, and it acts on and essentially, that would promote the longevity phenotype.
Yeah.
But then some of the literature says, it activates mTOR and it activates protein synthesis and it promotes hypertrophy. So very confusing.
Yeah, exactly. So this is why we had that discussion a few minutes ago, where it points out that sometimes this can be antagonistic, and there are factors at play that is very difficult to appreciate. So broadly speaking, the idea that if you ingest a whole bunch of protein, you're going to be activating that mTOR pathway. Because mTOR, if you're speaking about longevity, the broad idea is that you would like to inhibit that, to tell the cell, now's not a good time to replicate. We need to hunker down and try and survive the current stressful situation we're going through. The hormesis kind of effect, the what doesn't kill you makes you stronger approach. But if you have an abundance of protein around, the cell goes, oh, great, we must be having a feast right now, which is probably a good time for me to grow and replicate. Which, when you're in the gym, that's exactly what you're trying to promote. You're trying to promote growth and improvements in your body as a whole. But then we've found this antagonistic idea of it actually will inhibit mTOR as well and promote that hunkering down of the cell.
It's pretty interesting. So there was a study in... just to hark back a second as well. So that's another reason why a lot of people get on peptides. Amino acid supplementation, because like leucine and isoleucine are well known to be potent stimulators of mTOR. Not all amino acids are the same when it comes to affecting that nutrient signaling pathway. But where was I? I don't even know.
You were pointing at that fact before you went into something else. I wasn't sure where you were going.
Yeah, I'm a very multi-threaded thinker, and so the problem is when one thread finishes, I can't often pick up the other one.
I'm normally in a state to help, but not after a night shift, unfortunately.
No, that's more than fair. So yeah, I think I was going to talk about a Nature Communications paper, which was one that showed hypertrophy in muscles. And so what they did was they took a bunch of mice, supplemented them with alpha ketoglutarate 2% and 1%, and gave it to them for 8 weeks, and then looked and measured the width of their gastrocnemius muscle to see what was going on. And lo and behold, the gastrocnemius muscle was bigger. So they investigated why. And this was quite an elegant study. They looked at phosphorylation and activation of mTOR, as well as other markers along the mTOR pathway. And then they inhibited mTOR pharmacologically to make sure that it was the mTOR pathway that was being activated. And it was. So if you supplemented with alpha ketoglutarate and inhibited mTOR, then you attenuated that hypertrophy effect.
Yeah, you lost the increase.
Yeah. So definitely acting to promote protein synthesis and stimulate mTOR. And yet, another study in mice that took old mice, fed them in a similar way, 2% alpha ketoglutarate, and then looked at their markers of longevity and health span, showed a markedly improved health span. Not actually, interestingly, lifespan, but these were much healthier mice.
Yeah. It's a very little key point to highlight, isn't it? Most of this podcast, I've already said the word longevity, but really the evidence isn't strong in that direction. It's more about a health span.
Yeah.
So you're healthier for longer, and then because that's the way you want to eventually reach death, right? You don't want this slow decline and crumbling away. You want a very sharp cliff precipice. You want to be healthy one day and then dead the next. When you, it's a very morbid topic to discuss.
Well, it's just that survival curve problem, and people want to fall off the cliff. And so if you plot a survival curve, you want it to be as straight as possible and then suddenly collapse, rather than just slowly whittle down. And that's what they saw. So the end point was approximately the same, but less of a whittle, more of a free fall.
Yeah.
Interesting stuff in the Drosophilas as well. So the Drosophila experiments, maybe you know a bit more about it than I do, but from what I read about the Drosophila effects is definite mTOR inhibition on many metrics when you look at that. But interestingly, it affected things like the Drosophila's fecundity. So their fertility was less when they were on alpha ketoglutarate.
Yeah.
Which makes sense from that mechanistic perspective.
Because we're, again, getting back to those big, broad themes of it's not safe to be replicating the cell, it's not safe to be replicating the organism. We want to be hunkered down and try to improve our chances of survival. So, yeah, it does make logical sense that our ability to reproduce is going to be affected by that.
I mean, one thing that I really need to pass is, is the method of administration important? One thing I actually obsessed about a lot was like, because I was reading about, the pharmacokinetics of alpha ketoglutarate, and one issue that comes up with NAD supplementation as well is like, can you get this molecule from, bloodstream into the cell, into the mitochondria, and wherever it needs to be?
Yeah.
And chemically, this molecule is actually quite hydrophilic, which means it doesn't cross the phospholipid bilayer of a cell particularly well.
Yeah, it likes water, not fat, and the fat cell's made up of... a cell's made up of a fat lining. Yep.
Yeah, totally. And I did as much literature searching as I could, and it seems that it does cross into the cell from the bloodstream, which makes sense. But derivatives cross better, and so there are some interesting studies looking at precursors, I should say. So again, similar to how people have that NMN as a precursor to NAD. There's some. This is all animal literature. No one's tested anything yet, but some evidence with some endpoints that precursors work better for accumulating intracellular AKG. Not necessarily in the longevity space, but for certainly some other endpoints, specifically talking about like cellular damage and providing resistance to cellular damage and that kind of stuff.
But it's a whole nother field of study, isn't it? Trying to, we know this molecule works. We have some good understanding about how it works in the cell, but delivering it to the cell in a form that's going to allow it to do its job is a whole different kettle of fish entirely. The NAD, NMN, and NR pathways for all of this are really fascinating. I'm sure that'll be a focus of an entire podcast for us.
They are really fascinating. Sometimes I wonder how important all of that really is. to be honest.
Yeah.
And I say that because I just wonder, it strikes me that why should cellular aging matter that much? And that sounds like a weird thing to say, but it's just like we're not a cell. You know, what we are is like a manifestation of the behavior or the interaction of a lot of cells. And it strikes me that like the interaction effects are more important. And figuring out how to replenish old cells to maintain a young phenotype seems to be, I don't know whether I'm on the right track at all, but it would seem in my mind to be like a better strategy, which I think is where like senolytics come into play as like a more interesting strategy. But even then, like that's really simplistic to just like, I'm going to kill the senescent cells.
I see where you're coming from. It's a nice novel approach. I think I subscribe to the idea more than you. I think I like that heuristic of if you fix it at a cellular level, the cellular interactions should improve, and then the organism should improve on the whole.
Yeah. Here's where I disagree. And just because every tissue has like a stem cell niche, right? And so when cells become damaged or die, that stem cell niche activates and can theoretically just keep replenishing stuff. You know, classic examples are like the lining of your gut is constantly shedding. Same with your skin, constantly shedding.
Yeah,
and
6 weeks later, all your skin's new, right?
Yeah, and you have all these stem cell niches in these like areas that are hugely important for differentiating and forming new tissue. And that to me, knowing how cellular aging connects with the slow degradation of, or the lack of performance of stem cell niches as we age, is possibly more important, maybe.
And we touched briefly on that in the senescence podcast. Yeah. When those stem cell niches enter in senescence, then you've got a real problem, right? Because they're not able to replenish that sort of subset that they're in charge of.
What I'm going to say is like kind of, because senescent cells are like a hugely important mechanism for embryological development. And we're jumping back to senescence, but who cares? Because it's super interesting. Like in wounds, senescent cells are hugely important for promoting correct wound healing. And without senescent cells, you get deranged wound healing and like excess scar formation and
scarring,
terrible outcomes. And so it's and when you look at embryos and track what happens to senescent cells that are in embryos, they actually revert back to normal cells, or they die. And so you have this like temporary induction of senescent cells to regulate the tissue around it, and then they'll change back to regular cells or die.
We need to find that zombie cure.
That's interesting. That is interesting to me. And then just to quickly digress, you link in that with parabiosis. And so parabiosis is where you give an old mouse young blood. So there are all these crazy experiments, and they sound horrific because, to be honest, they probably are. But essentially, they'll take a young model organism and stitch it to I
can hear people cringing.
I know it sounds terrible, but it's and to be honest, it really probably is. But it's kind of the only way of testing to see if this works and figuring it out.
And it's a super interesting area.
Yeah. So they take these young mice, stitch them to old mice, and the old mice get younger, but the younger mice get a little bit older phenotypically.
It's crazy, like a sharing of the burden.
So they share the burden, and so you have these humoral factors, which are factors that are floating around in the bloodstream, which are regulating aging on a organism level.
Yeah, it's outside of the cellular sort of domain. We're outside of all the machinery that we love to talk about, and it's pumping around to all aspects of the body. That's probably the best articulation of your idea that there's a local cellular interaction and an organism as a whole. Again, like anything in medicine, right? The answer is going to be multifaceted. It's going to be some cellular processes that you simply can't ignore. It's going to be some cellular interactions that you simply can't ignore, and then organism behaviors or traits that you can't ignore either.
For me, it's a clock, right? There's something that's a clock that's ticking.
Yes.
Maybe it's a countdown.
Yeah.
It's a stopwatch that's counting down. And what is that?
Yeah.
What is that?
Yeah. That's what drives our whole curiosity, right?
And so on a cellular level, you can give people mTOR inhibitors. You can give people metformin. You can calorie restrict, dietary restrict, and you slow down the clock. But how?
Yeah. And how can seemingly very different or even opposing mechanisms come through with the same sort of effect? And I mean, it's not the full answer, right? These organisms that we study still die. We're not stopping the clock. We're showing in a lot of traits that we like the mice study with AKG, alpha ketoglutarate supplementation. They had this really fantastic frailty sort of framework that they applied. Frailty is a key word that every doctor's aware of, but it's this nice sort of way to summarize what it is when someone's old that makes them susceptible to disease. If you're asked to define aging, it's actually a very difficult concept to sort of put into words. But to rattle off a few key phrases, things like a decreased reserve, a decreased ability to handle challenges or disease processes as they prop up. And that whole sort of washy definition that I'm trying to put across is summed up nicely with the idea of frailty. So your degree of frailty gives a sense to how much you can withstand and how much you simply can't. And so this elegant mice study had a range of different factors they were measuring to give an overall idea of frailty, a frailty index. Things like how thin their skin was, how far they can see, how much energy they were demonstrating with their behaviors. Did they look like active mice or not? Their ability of the hair to sort of stand up on their skin, all sorts of different areas, which in and of themselves are pretty small data points, but correlated together build this really nice, beautiful picture of, is this test subject old or not? And that frailty index was significantly altered with alpha ketoglutarate supplementation. So you've got this young phenotype that's being displayed, but they still die. I mean, it's not the whole answer, right? And I guess would you categorize yourself as someone who's more interested in lifespan extension or health span extension?
Look, I think if I had to pick one, it would definitely be health span.
Yeah.
And like nobody wants to linger around like being decrepit. So I think that's a universal. Having said that, I also want lifespan extension because I personally feel like I just don't have enough time to do all of the things that I want to be doing. And,
right.
And I just look at like the next 50 years and I'm like, how can I get from where I am now to having done all of these things? Because life is the gift that just keeps on giving, right? It's
yes. I love your optimism. This is
it's
a
the
fantastic
best choose your own
approach.
adventure, and like I just, I feel so hamstrung by time. It's actually a cool movie that I quite like. Maybe the execution of it was not brilliant, but I still really enjoyed it. Called In Time.
With Justin Timberlake?
Yeah.
I knew that you would like that movie just as much as I did because of our interest in longevity.
Yeah. But I really liked that movie, and I just loved the way they played with that idea of like time running out, but still having like a youthful phenotype.
Yeah.
I quite
For
like
anyone who hasn't seen it, these characters they're sort of stuck in their current age. They never grow older. They've got this watch or this sort of digital clock thing that's counting down on their arm, and if that hits 0, they die. But otherwise, besides an accident, these people won't pass away. Which, like any sci-fi movie, is taking the cool concept and sort of forgetting a few of the other key ideas and things like that. But I mean, it's not meant to be a scientific educational endeavor. It's an entertainment piece, and I love the idea. It was good.
It's really cool. The idea of converting time into a currency was what I thought was really interesting, because it really, in many ways, is. We choose to spend, like, it's playing with that idea of spending time, but we do choose to spend time in various ways, and
I'll trade you these next 12 hours of my life if you agree to give me X amount of dollars per each of that hour.
Yeah. But the curious thing is, like, whilst you might be able to spend money and get more money back, you can never spend time and get more time back.
Yes, that's right.
But what if you could? And that's kind of like an idea that I really quite liked from that movie. But I mean, we won't get there. It's science fiction.
Yes. But it is if you can increase lifespan and health span, and then the way society will function will appear very different, right? That's probably a good podcast we can do in and of itself, the implications of extended lifespan and health span. Well, what does that mean for how many years that you would want to work? What does it mean for retirement? What would it mean for... Right now, there's a large part of our society dedicated to looking after the elderly, because we almost universally agree that they need our assistance, right? They're growing in their frailty, and we need to be there to support them, which obviously I agree with. But if that was no longer a necessity, what do you do with that vast industry, and what would you now do in your twilight years if you have the same cognitive and physical capacities that you do as a 30-year-old? What new feats and endeavors can we reach as a human race in terms of world records of physical endurance? If you've been running your 100-meter sprint for 40 years, surely you're going to be better at it.
Yeah. That's a cool idea. That's a cool idea to play with. We should definitely dive deeper into it.
And I think the mice study that showed that increased health span, their mechanistic approach was showing that you could inhibit the AMPK, which we've touched on a few times before. That AMP kinase that senses when we've got low energy, so we haven't got much of the ATP, adenosine triphosphate, and got a lot of the AMP. So essentially, this is taking a supplement, AKG, to trick your body into the same effects that we're trying to promote with calorie restriction or fasting, right?
Yeah. One of the other mechanisms that's interesting is it directly inhibits an ATP enzyme, an enzyme that makes ATP. So that's another way that AKG is actually inhibiting energy production and potentially simulating a starved phenotype from a cellular perspective.
That's an enzyme in mitochondria, right? Complex 5?
No, not complex 5. It's a specific membrane. I can't remember where it is now, but it's like there's a specific enzyme that maybe it is complex 5. No, I don't think it is. Either way, ATP down.
That's the takeaway message, right? ATP down. As you've pointed out before, heuristics are important, and that's that you're onto something when ATP down is the result, and ATP down works for metformin, it works for calorie restriction, it works for fasting. Okay, we could be onto something here. This is all matching that same idea. Maybe this is worth studying, and then you do these small animal studies, and it's true, it's working.
What's weird though about AKG is it's not just like we mentioned, it was not simplistic, and it really is not, because it's also a precursor molecule for amino acid synthesis and a whole bunch of other things. So it's an important carrier of nitrogen in the cell, and so it sits in this like intersection between the Krebs cycle and like amino acid synthesis and a central metabolic figure.
Yeah,
one would say.
Is that dose dependent? Is that time dependent? Should you, if you take half a gram versus a gram, you're going to be pushing it more towards that mTOR activation rather than mTOR inhibition?
Now that's a really interesting question. Is it dose dependent? From memory, the study that showed decreased frailty in old mice was 2% AKG in the chow, and the one that showed increased hypertrophy of the gastrocnemius was 2% in the chow. And I'm pretty sure these mice were fed ad libitum, so they could just eat as much of the chow as they needed. Which is probably a bit different to the way you might supplement AKG in the gym, where you might like throw it in a shaker, but you're probably not, supplementing it with every meal at a 2%.
yeah, that's very true.
It's sort of a bit hard to know what the dose equivalence would be for a human, even if you wanted to. But 2% of all energy intake, it seems quite high.
Yeah.
Of all food intake.
Yeah, talking about a human diet, that would be rather unrealistic, wouldn't it? But these are all questions that I'm sure will eventually be answered. And again, we're full circle now back to the point where we're at the cutting edge of this. We're right on the tip of the wave. And we wish we had those answers, but we know we're heading in the right direction. We know this is a good wave to be on. And again, it's a very safe molecule. There's no real adverse effects. How long have you been taking it?
Not long, to be honest. It was really only when I became aware of the literature. On it. So probably sometime this year I started it.
Yeah, I think I'm only a few months into it as well. I've had it before, years ago. Not with a view to longevity. It was all about the gains back in the day.
Yeah. I've definitely dabbled with pre-workouts in the past, but I don't know if any of them had AKG. I don't think so. Maybe they did.
I think so. A lot of some of the nitric oxide marketed pre-workout stuff.
They put it with Arginine, which is a vasodilator. Yeah.
And I looked into that too in case we got onto this topic.
Yeah?
There were 5 or 6 studies that really wanted to go through and elucidate whether or not having that arginine would produce any increased nitric oxide. So the broad concept here, folks, is that you're trying to give a supplement that's going to increase nitric oxide. And anyone with a heart condition will tell you that nitric oxide is something that will improve blood flow, sort of dilate blood vessels and get more blood pumping. Yeah.
Exerts its influence.
So
nitric oxide. That
was sort of put to the test in a few studies, and reading their methodology, some were definitely better than others, but by and whole, good science. Something that I'm happy to, put my flag to as well. Yeah. And no real significant increase in nitric oxide production or blood flow increases. There was some were saying, a mild effect in sort of a nuanced area, kind of saying it won't hurt, and if it works for you, go for it. But the placebo effect is real. But
in these studies you looked at, were they looking directly at nitric oxide, or were they looking at other endpoints like hypertension, for example?
One included hypertension, but the majority were looking at nitric oxide production.
Because when I was looking at buying a AKG, it comes packed with Arginine most of the time when you're getting it as a supplement. Whereas all the studies, it's important to note this because they are different. Most of the studies most of the studies are done as a calcium salt, so it's bound to calcium. So when I was buying it, I was like, I'll just get the Arginine. And so I did some like research myself, and I was just like, looks like it's okay for hypertension. But I didn't knuckle down and like really. I was just like, okay. So I looked at some studies that had the endpoint of hypertension, and it seemed to have a reasonable effect on hypertension. But I didn't look at any studies that had a harder endpoint like nitric oxide production directly. So I'm a little bit unsure on that one.
Which it was softer, which then, a good scientist points out that maybe it's achieving that lowering of blood pressure via a separate mechanism somehow, which, you know, I wouldn't bat an eyelid to in any sense, because we've spent a lot of time pointing out in this podcast that it will do a lot of jobs, and we're not sure of all of them.
Yeah. What I would want to do, though, is a rigorous study where you have a randomized trial where you randomize one set of bros to placebo and another set of bros to Arginine, supplement pre-workout, have a standardized workout, post-workout, bust out the calipers and measure some veins. And then do a crossover study, so you're getting like a direct.
Something over.
Crossover is important. And then have another endpoint of the objective observer, more or less swole to the objective observer.
That's a difficult category to summarize, but I see your point there. Yep.
Those are the endpoints I'm interested in.
For truly altruistic reasons as well.
AKG.
It's definitely a fascinating area. It's one that points out the health span benefit as opposed to the lifespan benefit. And then even if it is activating mTOR or producing the protein synthesis pathways, if you're taking it after a workout, which is when I take it, my father-in-law work out together quite a bit, and we'll have that in our protein shake after a workout. And I think that's probably a good place to have it. Either I'm going to get the protein synthesis benefits post-workout from this molecule, and if I'm having a health span benefit as well.
Here's a reason why not to do that.
All right, hit me with it.
So I was looking at so there are some interesting research that's shown that AKG is actually an important molecule for mediating the effects of resistance training specifically. So the hypertrophy effects of AKG or of resistance training are sort of part. So if you block AKG, you attenuate the effects of the resistance training and exercise. And so my argument would be that taking the AKG is in a sense kind of like a mimetic of resistance training. And so if you've just done resistance training, what's the point? Because you've literally just done it. And perhaps you should be having AKG when you're fasted, or like, in the morning when you haven't done a hard workout and have potentially a lot of intracellular AKG already. That would be my argument. And so that way you're doubling down rather than sort of trying to complement it.
Yeah. I mean? So trick your body into having a resistance-based workout when you're not working out, and then work out later, so you get both effects.
I guess, maybe if you went for like a really long cycle, maybe like an endurance training, it might be useful to help
replenish,
and also to stimulate more hypertrophy than endurance training otherwise would. Because normally wouldn't. Yeah.
Maybe I'll change my practices. I'll have to have a think about that.
That's a hypothesis. I mean, it's a very mechanistic hypothesis. It's definitely not an evidence-based recommendation in the sense that there's no hard evidence for it. But as far as we know, mechanistically, that might be a reason to change.
A key concept. Yep.
Yeah. Just as a disclaimer.
Yeah. Yeah, this is all very fresh science, isn't it? This one of the studies we're talking about was September of this year, right?
Yeah.
Right? Yeah.
Despite being discovered in the 30s.
Yeah. Like a lot of things in, it's like fashion. It comes back into trend, comes back under the microscope, so to speak.
Yeah, definitely. Still so many mysteries.
Definitely. And delivering that to the cell, that you mentioned before, that's a huge mystery. I'm really interested in that sort of stuff. I did my chemistry major was what I focused on in my undergraduate degree before medicine, and I love this sort of stuff. I love drawing out the molecule. I love comparing it to its precursor. Oh, this one's bigger. Yeah, that'll probably have more trouble getting inside the cell unless there's a transporter. Oh, this transporter seems to fit that really well. Okay, this is interesting.
I'm rather ashamed to admit that biochemistry at one point was a little bit of a weakness of mine. And I'm on the record as it being a weakness. So when I was as an undergrad, I did a number of degrees, and on one particular semester I overloaded a lot. So the recommended number of units for that semester was 12. A full-time load for study was 12 units. I had overloaded and I had put in 24 units. So I was doing a lot of subjects at the one time, just out of sheer hubris. And that semester I achieved a high distinction, a distinction, a credit, a pass, and a fail. So I had
full spectrum.
I had the full house, and the one I failed was biochemistry. You can't overload that much and do biochemistry. It's actually really hard.
A valuable lesson was learned that year.
Yeah, a valuable lesson was learned. Know your limits. But to be fair, you know what? I didn't know my limits then, and now I do. So.
Yeah, I mean that sincerely. That's a beautiful lesson to learn.
Yeah, I'd encourage everyone to push themselves to that point.
Yes, yeah. Find out where that is. The best motorbike riders in the world only know how not to fall off after they've fallen off a lot of times.
Absolutely. In safe, controlled conditions.
Yes, on a racetrack with big runoff areas and medical staff at every corner.
Off a motorbike, it's never been a safe, controlled condition.
Yes, true.
One time I was riding home one night, and I like a complete idiot, I don't know what I was doing. I just phased out I don't know. And my handlebar hit a rear vision mirror of a ute. Not rear vision, the side mirror of a ute. And it was a beefy side mirror. And fuck, man, I just span right out and was gone.
Ooh, a lapse in judgment.
Definitely a lapse in judgment. So for me, I do still have a motorcycle, but it's not. I haven't ridden in a long time. I don't trust myself. To be honest. Yeah.
I've got my dream motorbike sitting in the shed right now. Yeah. But I only ride it in the perfect conditions. I ride it when I'm in the mood to ride, the sun's out, the road's warm, there's not too much wind, all these things. Before, I used to use motorbikes as a mode of transport and enjoyment. But since having my baby girl, it's the risks are real and high, and it's silly to ignore them.
Yeah, definitely.
And I'm not afraid to ride the bike, but I'm going to ride it in the perfect conditions. One, because it's a lot more enjoyable, and two, I'm going to decrease my danger.
Totally. I think to disagree with you slightly, I'd say the risk is maybe it's higher than if you drove a car, but the risk is not necessarily high, but the consequence is worse.
Yeah. That's true.
And it's always an important discrimination, the risk versus consequence.
All right. Well, there's a range of topics we can go into next. Yeah. I'm keen to get onto the NMN and NAD pathways, I think, at some point.
Well, we're on we're on a very much an intracellular train, so we might as well just keep the dream alive. Yeah,
and then we'll slowly zoom back out and try and put it all together.
Totally.
Hopefully people were able to follow along. This is a topic that is difficult to listen to just the audio. A lot of mechanistic pictures seem to help with people's understanding in a big way. So key things people can look up is the Krebs cycle or the TCA cycle, ATP, production pathways, all these things. If you're looking at those whilst you're listening to this podcast, it could help. But basically we're talking about AKG producing the same sort of pathways as fasting and increasing health span.
Sometimes.
Sometimes, yep.
Yeah.
Sometimes.
Well, it seems to increase health span most times, but how it does that
is the question. Yeah.
different sometimes.
Mm.
Yeah.
All right.
Interesting.
Thanks so much, mate.
So next time we're talking NAD.
Yeah, I guess. Oh, it could change, but let's see what happens.
See you, man.
See you, mate.